So I have to redo the video because I ran out of storage on my other one. But I'm going to speed run the first part because it's pretty simple. So my key components, I had 5 components in this total. My ESP32, my ESP32 terminal board, my relay board, my brick, and my actuator. My actuator was the piston that allowed the door to push open, but that is what I'm going to talk about last. First, I'd like to speak about my ESP32 and what it has to do with the ESP32 terminal board. My ESP32 is my motherboard. It connects all things, and it controls the relay, controls the power brick, controls everything that has to do with my project. What the terminal has to do is the ESP32 connects into the terminal. The terminal is like a wire extender. Like, let's say you don't have enough like wire cable length to, plug your wire into the wall. Like, that's what the ESP32 is for, basically. But it just adds more plugs. So instead of one 5-volt plug, I had 3. Instead of one ground volt plug, I had 6. That's what it did for me. So the way I turn my ESP32 on is by plugging a USB chip into the microchip into the ESP32, which then plugs into my computer through the side holder, or whatever it's called, the side plug. So after this, my ESP32 would be turned on, which then later I would have to plug into my relay board, which had screw terminals. So I had to use a male to female jumper wire to connect these. This is the only thing I would be using jumper wires for, as it doesn't really help me in the future, as they don't provide enough voltage in general to power the power brick, because the power brick is, I think, 110 watts or something. Basically, I'd plug 4 wires. So one of them would go into the 5-volt to connect the power. One of them would go into the ground to also connect more power. Another would go into D26 into D27. Now, what these would do is open and close the door. So let's say my actuator wire, well, we haven't gotten there. I'll bring it back later. So first off, I'd like to talk about the screw terminals. There's 4 screw terminals: in 1, in 2, out 1, out 2. What these terminals do is they basically tell the relays whether to turn on or off, which would later come in handy when I write my code during the end. So what do these relays have to do with the brick, and how does it turn the actuator on? Well, first off, I would like to start by saying the other side of the relay has 6 ports, which would be NC1, NO1, COM1. That'd be one like relay brick, and then it would be NC2, NO2, COM2. This COM1 and COM2 would go the actuator wires, because the actuator wires are what's powering the actuator, not the brick. But basically, connecting the actuator wires to the relay would tell the relay that, okay, I'm connecting the actuator, like I'm telling the actuator what to do. However, I don't have a power source. So how do we get a power source from the actuator without having it plugged into the power brick? That's where the NCs and the NOs come in. So this is where I messed up. So I almost ruined my project by using jumper wires, male to male, in this. You're not supposed to do that. It doesn't provide enough voltage, and it just doesn't give enough power in general. It takes forever. It makes your project very faint. You can barely see it. It doesn't even look like it's turned on. Anyways, so I had to swap to a long electrical cable, which I'd later cut into 4 pieces with the wire cutter. I'd strip them down like an inch off both ends so it plugs into both. Very thick wire, very heavy duty. Worked great. Gave enough power. I was worried it might supply too much power, but it clearly didn't do that. It worked well. But what this did is I'd plug 1 into my NC1, and then I'd plug that wire into a V+. Now, the V pluses and V minuses are basically what is telling the power brick to do. Like, is it supposed to be negative or positive? That's also connecting to how the actuator works. Because that also connects to the relay. The power brick is connecting to the relay clicks. So let's say for my project, as you saw in the video, 1 click does nothing. It stops it. It's like idle. 2 clicks, it extends. 0 clicks, retracts. And they have lights to indicate whether it's clicking or not. Well, not clicking, but it clicks once, okay? Anyways, these power brick, so we have V plus and V minus. But before I get into that quick thing, power brick plugs into the wall with 3 wires, 2 gray, 1 black, 1 green. The green always goes in ground. Pretty self-explanatory. Just powers the power brick when it plugs into the wall because I need a power source, right? Anyways, going back to the electrical wires. The electrical wires colors don't matter, and I learned this, that the colors of the wires do not matter unless it's like an actual like thing. Like for example, the actuator. The colors do matter because the wires are different. For example, the red wire had less amount of wires. They were less thick. They were less in general, and the black one had more wires. So this is like, again, my next point. The black wire on the actuator. The black wire means retract. Red means extend. I had to figure that out the hard way. I messed up a ton of times doing this, but I did end up figuring it out in the end, and it was actually pretty easy once I did. But yeah, that's how that works. Now I'm going to move on to the coding. So the coding is the most complicated part. Of course, AA had to write it for me, but the troubleshooting problem was me, myself, and I. I had to go into Arduino, troubleshoot the problems that I had with the AI, and basically rewrite it. Well, not rewrite it entirely, but just fix the problems that it had, because for some reason, some of the times it wasn't clicking the relays, it wasn't connecting, which then I had to use a new USB, which I later figured out that my USB short-circuited, I think, or just like broke in general. I think I like hit a wire or something. But yeah, that's basically it. The coding part took a long 5 hours. I don't know if I'm supposed to talk about this, but next project, Mr. Frisky. I'm thinking about making a double sliding door, automatic door opener and closure, and I'm going to do it from the top instead of the bottom. So it's accessible and quick. And I actually explained my project. There you go.